Our infrastructure in the U.S. is aging. As it ages, we must look to technology as a tool to diagnose potential problems. These are only one component of our infrastructure, but the technology discussed here could easily be adapted to inspect all major infrastructure. The study that I'm citing ultimately took place in Korea. However, the technology can be used anywhere in the world. In this study, an unmanned aerial vehicle, or drone, was used to inspect various types of bridges. The drone is equipped with several pieces of technology that allow it to interact with the bridge and the feedback data to the operator. The units mounted on the UAV include DSLR camera, a GPS unit, two types of LiDAR. These units are mounted on a gimbal to keep them stable. This stability is key to getting the best quality images. In addition, there is a mini PC and an LTE modem to transmit data in real time. It also must carry batteries to power the equipment and the drone itself. All of this equipment together creates an unmanned aerial system, also known as a UAS. While there are commercial production units available that could carry the payload, a quad-rotor drone was designed specifically for this study. After the initial flight, a 3D digital rendering of the bridge is made. This model allows for waypoints to be programmed. A flight path for the actual inspection flight is designed, and the UAS can fly according to the waypoints and the flight path in order to gather detailed images and measurements. After the images have been checked for quality, they are fed into a deep learning network. The network has used upwards of 4,000 images to learn what to look for as far as defects in the structure of the bridge. The defects that it was trained on for concrete bridges include cracks, efflorescence, breakage, water leaks, material segregation, and rebar exposure. The criteria for steel bridges were corrosion, cracks, bolts, defect in welding, and paint peeling. Being able to use the data from flights to take detailed measurements of defects allows engineers to better prepare for the repair process. After the flight took place, the images were enhanced and fed into the deep learning network. It was found that the UAS had an 85 to 100% accuracy rate among the bridges tested. Bridges that had multiple defects in one area scored lower for accuracy. This study acts as viable proof of concept for the technique. I believe that this technology will only improve with time as does most technology. While it doesn't eliminate the need for human inspection, it has the potential to dramatically reduce the manpower needed to complete the task. Thank you for listening to my presentation.